Discovery Houston back with you, and with good downlink video from the payload bay.
And Houston, we hear you loud and clear.
Microgravity, also known as zero-G. Microgravity is quite literally a state of very weak gravity, about 1/1,000,000th of what we feel on Earth. For nearly 40 years, NASA has been conducting research in the microgravity environment of space, performing experiments and making discoveries that benefit people on Earth. How does scientific research in microgravity differ from research conducted in 1G? How does the human body react to weightlessness? What does it feel like to float free, untethered and weightless, when there's nothing to hold you in place? If you were offered an opportunity to perform experiments in microgravity and experience the sensation of zero-G, would you do it? Since the mid-1990s, more than 800 college students, the next generation of scientists, engineers, and astronauts have done exactly that. This is their story.
In 1995, the National Aeronautics and Space Administration created the NASA Reduced Gravity Student Flight Opportunities Program, also known as the Student Campaign.
The Student Campaign is a highly competitive annual program which provides a unique academic experience for undergraduate students. Students from around the country form teams to propose, design, fabricate, fly, and assess a reduced gravity experiment of their own choice over the course of 8 months. If their proposal is selected, each team travels to NASA's Johnson Space Center in Houston, Texas, for a flight aboard NASA's KC-135 microgravity research aircraft. NASA has been flying its reduced gravity program since 1959. From the early days of the space program, through Mercury, Gemini, Apollo, and the Space Shuttle, the KC-135 has served as a flying laboratory where scientists have conducted research in fluid physics, combustion, material science, and life sciences. The KC-135 is also used for astronaut training and as an engineering test bed for developing and testing new technologies before they're flown in space. The aircraft was also used during the filming of the motion picture Apollo 13. Director Ron Howard, along with Tom Hanks, Kevin Bacon, and Bill Paxton, spent several weeks filming weightless sequences for the film in the microgravity environment of the KC-135. The pilots are able to create brief periods of reduced gravity on the KC-135 by flying a series of parabolic arcs. The plane climbs at an approximate 45-degree angle, then noses over into a 45-degree dive. This creates about 20 to 25 seconds of microgravity.
When you first see the KC-135 at Ellington, it's a pretty impressive sight. When you walk up close to the front of the aircraft, you can see a diagram of the parabola that it flies painted on the side, and it says, weightless wonder.
It has NASA's emblem right there on the tail, and so it was pretty cool to think, you know, I actually get to fly in that. I don't just get to watch.
The first thing a team does when it arrives in Houston is come to Ellington Field for orientation for the program and for the Ellington Field aircraft procedures.
Typically, when all the students arrive, we welcome them. We have a welcoming ceremony where we brief them on the do's and don'ts here at Ellington Field. We'll brief the students on what to do, what not to do, and they'll begin their setup of their hardware, go through getting everything squared away, getting it ready for the test readiness review, which will follow during the week.
When you first get to Houston, there's a lot of things you have to do once you get here. You know, a lot of people have really big experiments that they pretty much have to reassemble once they get them to Ellington.
The test readiness review is the last step in the safety review process of the experiment packages that we fly on the aircraft.
All the switches are numbered and the subjects have been trained as to what switch is what number.
The experimenters describe to us what they're going to be doing. We look over their experiment, and this is kind of the last line of defense, I guess you'd say, of identifying any potential hazards with the experiment.
NASA is really focused on safety, so before students can fly on the KC-135, they must pass a flight physical and take NASA's physiological training course.
Then you also have to get in the altitude chamber, or they call it the hyperbaric chamber.
The altitude chamber is It's a training device, basically, just pretty much like a classroom, except it's a big metal box with regulators and other things inside.
They simulate what the air would be like at 25,000 feet, and you experience that. And the main point is to determine what your symptoms of hypoxia would be, or oxygen deprivation.
Some people, their fingernails turn blue. Some people, their lips will be a little bluish. Some folks get a little happy. Some folks just get a little bit dull.
The strongest symptom that I felt was I felt lightheaded. After about 4 minutes, I could tell, I can tell my body is not getting what it needs right now.
After the students have completed their chamber ride and are certified for flight, it's time to relax with dinner at a local restaurant. Then it's off to bed for a good night's rest in preparation for the big day.
You have to report to Ellington pretty early in the morning, at least early for a college student. I think we had to be there at 7:30. And so I was pretty nervous. I was anxious. I mean, you really honestly just don't know what to expect.
We'll issue them their flight suits, because everyone who flies on the aircraft must wear a Air Force approved Nomex flight suit.
And you, of course, fill the pockets in the flight suits with your motion sickness bags. They also give medication to those who want it to help with the motion sickness.
Then we'll, at quarter of the hour, 8:45, we'll go ahead and hold a pre-flight briefing. And then as soon as that briefing is over with, we board the aircraft and we get ready to fly.
When you first get on the aircraft, there's a sense of anticipation and excitement. You're finally going to do it. You're going to get to go out here and see what it feels like to be weightless.
The majority have never flown on this aircraft, and they've heard the stories of the KC-135, so there's a little bit of apprehension and nervous tension there.
Shortly after takeoff, the flight crew releases you to get out of your seats and you can move about the aircraft, and I think that helps a lot toward the nervousness.
And at that point, it's probably about 10 or 15 minutes before the first parabola begins. During that time, people will make final adjustments and get strapped in or whatever they need to do to set up their equipment for operation.
Once we take off, we'll head south over the Gulf of Mexico. Once the air traffic controllers at Houston Center have cleared us into the area and given us altitudes from 26,000 feet to 39,000 feet, the pilots will begin our air work.
We'll get at about 26,000 feet, giving ourselves a little pad from the bottom, get up to max indicated airspeed, which is 350 knots, then start a 1.8 G pull-up until the speed is bled down to 240 knots, which is usually about a 50-degree nose-high attitude.
At that time, while we're climbing, everybody in the aircraft is experiencing about a 1.8 G pull. So if you weigh 100 pounds, it makes you feel like you weigh 180 pounds.
And I remember one of the flight conductors said, "That's 2G, that's the worst that it's going to get. You're about to experience 0G.
Once we hit 240 knots, the left seat pilot will start pushing on the yoke, and the right seat pilot will pull the throttles back close to idle.
As this rotation begins, that's when the microgravity period begins. We're basically in a free fall at that point, the airplane and everybody inside it. The nose will continue falling through the horizon until it's roughly pointed 45 degrees nose low.
And then the next thing you know, I heard John Yannick holler out, "Over the top!"
Over the top!
And then, all of a sudden, everything just gets weightless. And, I mean, it's the most incredible feeling. I can't come up with a good description of, what it feels like that first time you feel 0G.
Oh, this is awesome!
One of the great rewards that we have as program managers of the program is to fly with first-timers, particularly on their first couple of parabolas, because just the experience of zero gravity causes them to spontaneously yell out and scream and other expressions of surprise, because it's just, as I said, unlike anything they've ever experienced before.
It was just really incredible. I was glad I floated free the first time, because it was just, that first parabola was just the best.
Just as you kick over the top, the photo floods come on, and the inside of the aircraft is just bathed in this brilliant white light. everyone starts floating and people's feet kick up toward the ceiling. It's almost as if you're in this dream world and everything is in slow motion. It's very bright and sharp. And, I just remember my senses were so heightened.
At 30 degrees nose low, we make a call over the intercom to the back to let them know that we're getting close to pulling out, because, of course, everyone needs a heads up that G's are going to come back on the aircraft.
30 low. 30.
When we get the 30 low call from the pilots, we will yell, feet down, coming out. That's your cue that within 3 to 5 seconds, G's are coming on the aircraft. We want your feet planted towards the floor, not your back, your neck, or any other part of your body. We want you to land on your feet.
And between 40 to 45 degrees nose low is when the pilot will start to pull out. And he'll play his pull out to try to arrive back at 26,000 feet, 350 knots again, and we'll just go right into another one.
After the students have experienced the first few parabolas, they get right to work, operating their experiments and gathering data, just like any NASA scientist or researcher.
After completing 30 parabolas, we generally fly a lunar parabola. This one simulates the gravity that Neil Armstrong and the Apollo astronauts felt when they were on the moon. Then we treat the students to a Martian parabola.
I can live on Mars. I know, this is great.
After the Martian parabola, we fly back to Ellington for a hero's welcome, a family photo, and a flight debrief.
The ramp there was just crowded with people, you know, clapping and ready to welcome us back and talk to us and see how we enjoyed it.
For most of the students who fly with us, it's the experience of a lifetime, something that they'll remember and talk about for the rest of their lives.
For so many people, it's the closest that you'll ever come to experiencing what an astronaut experiences in space. And so it's just such a privilege, I think, because you feel like you're part of this elite group that has just, you know, gone through something that so few get to go through.